things when you're going beyond model of Cassini, which is currently orbiting Saturn. So that is the largest spacecraft we ever built. In reality, it's about the size of a school bus. So yeah, and they have our full-scale model over at the California Science Center, if you've ever been over there. So that's a beast, yeah. And then in the back corner there, that is a 1/3 scale model of a spacecraft currently orbiting Earth called SMAP that measures the moisture in the soil around the planet. Okay? So that's what that is, and you'll see them all in the video, so I just wanted to make sure at least you knew what was what.
These are the models. This is a Cassini, a half-scale, jointed.
The European Space Agency and the Italian Space Agency, Cassini began orbiting Saturn in June 2004, carrying 12 instruments. The mission is an intensive study of Saturn's rings, its moons, and magnetosphere. Magnetosphere means the electromagnetic field surrounding it. Cassini released the Huygens probe, Huygens probe towards Saturn's largest moon, Titan, and the probe successfully landed on the moon's surface in January 2005. There's a model of the probe right here. And this is 1/4 size, so the real probe would be 4 times bigger than that. That's pretty cool, huh?
Yeah. So we have to get all our flight project guys involved just to handle the model.
Why is it gold?
He was just explaining that.
Titan.
The gold material both protects the probe. Do you remember what it's like getting sand kicked in your face? How that hurts? Yes?
It's uncomfortable, yes.
Yes. Well, what if the sand was traveling at 100 miles an hour? Okay, so little tiny particles of meteors that are the size of dust are flying around in space, and this gold stuff helps protect the probes and the big satellites from getting beaten up by all of the pieces of sand.
Is that tape?
Well, you know, it's a combination of different materials.
2014 soil moisture active passive, a 1/3 scale model of the soil moisture active passive observatory SMAP. SMAP will globally map soil moisture and landscape freeze thaw every 2 to 3 days. Measurements will be made by radar and radiometer with a 6-meter 20-foot rotating antenna.
That's the way the spacecraft moves in real life. And then when we launched it, that big thing had to be folded up. So the real spacecraft, that's like a trampoline. It's like 20 feet across. But on this model, they made a model version of that. So that folded up would look like this. So it shrinks down. It's almost like one of those little easy up pop-up tents. But just it's pretty cool.
Cool. Interesting.
Because you got to get it in the rocket, so everything folds up. Yes, the solar panels are all folded. Like these, this would actually be straight across, but one was folded across the, like the arms across your chest and stuffed it in the rocket. And they were really worried about this thing popping open correctly, because if it didn't, you can't fix it. So we tested it like 20 times here on Earth. Open. So. And thankfully it worked. But yeah, so that's what that's doing. Any other questions about stuff, guys? Everybody seen everything?
Mars Reconnaissance Orbiter half-scale, carrying the most powerful telescopic camera ever flown to another planet. The Mars Recon Orbiter shows Martian landscape features as small as a kitchen table. 5 other science instruments and the spacecraft's radio add to our understanding of Mars' changing climates, geologic history, and potential ability to harbor life. Launched in 2005, the spacecraft also provides a critical communications link between surface missions and Earth. Those are the nuclear carrying power thingamabobs. Voyagers 1 and 2 were launched in 1977 to meet a solar system alignment that occurs only once every 176 years. Both spacecraft sent back valuable pictures and information of Jupiter and Saturn and their satellites. Voyager 2 sailed on to explore Uranus and Neptune. Engineering subsystems provided power and stabilized the spacecraft. Onboard computers controlled flight and transmitted data to Earth independent of human control. These systems made the Voyagers the most intelligent spacecraft ever built. The Voyagers now are exploring near the edge of our solar system and will return useful data well into the 21st century.